folks, welcome to example 4, and this one's going to be a big one. So we're going to learn a bunch. I'm going to focus on this AC method, but I wanted to give you a couple of other formulas that could possibly happen when you factor a trinomial. So if you have a perfect square trinomial, what that means is you have x plus y, that binomial squared, right, or x minus y squared. If you recognize that, and again, if I did x plus y, I just want you to see how do I get from the right side to the left side of this equation. So if I were to FOIL this, first would be x squared, right? Outer would be x times y. Inner would also be x times y. And last would be y squared. And outer and inner are like terms, so I could simplify this to x squared plus 2xy plus y squared, because 1xy and 1xy is 2xy. So that's where this formula is coming from. So if you see a trinomial and it follows this pattern that it's x squared plus 2xy plus y squared, you can factor it into this perfect square trinomial, or perfect square of x plus y, right? X plus y with parentheses, protected with the parentheses squared. And if that linear, or that term in the middle has a negative, you could make it x minus y squared. And I would say for this comes with experience. All right, so I can recognize perfect square trinomials now, and I don't mean that in a braggy way, I just mean I've been doing this for a while. So I can probably jump from here to here automatically. And let's say you're not there yet, totally fine. The AC method will get you there, okay? Now the AC method, there are plenty of ways to factor. I wanna be clear, and you might have learned different ways. This is more of a step-by-step method that will definitely get you to an answer, right? Or maybe at the end of this, we decide the polynomial is prime, but this method will work. It takes longer. I want to be super clear. This takes longer. I don't usually use this method anymore. I usually use guess and check, but I want to show you a method that is exhaustive, that gets you to an answer, right? Because sometimes folks are like, dude, I need to be able to get to an answer. Totally reasonable request. And we're going to take a look at that. So we're going to look at a polynomial, really a trinomial, ax squared plus bx plus c. We're going to start, for right now, the problems we're about to do are when a is 1, okay? Things get a little bit more complicated when a is any other number. We love when a is 1. It makes our process simpler. Not necessarily easy, but just simpler. And we're going to multiply the coefficients of a and c together. We're going to find their product. That's where this becomes the AC method. So we'll take a times c, whatever that number is, great. And then we're going to list all the integer pairs whose product is equal to AC, okay? And so when we list all the possible products, positives and negatives, then we're going to circle, well, and I'll talk about this a little bit more. We're going to find out of those pairs which set sums to a number equal to b, all right? And we're going to find the one that unlocks, and I'll show you what I mean by that. So we're going to make a whole bunch of integer pairs. We're going to list a whole bunch. One of them, or at most one, will sum to b, and that's going to be the pair that we're going to want to keep. Once we get that, we're going to split the middle term, all right? And I'll talk to you a little bit more about how we're going to replace the middle term bx with the sum of like terms using the circled pair in step 2. I know that sounds like a lot, but I'll show you. Then we're going to factor by grouping, and if we want, we can check using the FOIL method. All right, so let me go through a couple of these with you. And just note that for every single example, well, with the exception of example E, we'll get there, but every example in example 4 has a lead coefficient of 1, right? You see a 1, unsaid 1 here, an unsaid 1 here. But let's try out this AC method. Again, with the full acknowledgement that there are plenty of other factoring methods out there. All right, so I'm going to go ahead, and for example 1, I'm going to say A is 1, right? B is 18. C is 72. All right, so if I start to do the AC method, and let me scooch my paper up even more just because I'm going to need all of this room. Okay, so I've got, oops, let me just scooch this a wee bit more. I think that's, oops, and now I'm losing focus. Hold on. Sorry, sometimes when I move my paper, my camcorder can't handle it. All right, so we're going to do the AC method. So I'm going to look at this product. I always want to look at AC, and in this case, that's 1 times 72, right? So that's 1 times, right? We're doing the product of A times C, which would be the number 72. And what we're going to do is we're going to list out all the possible integers that multiply to 72. So we could have 1 times 72, right? Or we could have -1 times -72. We could have 2 times 36 or -2 times -36. We could have, let's see, I can do 3 times 4 or -3 times -24. And I'm going to keep on going. 4 divides into 72, so I could have 4 times 18 or -4 times 18. 5 does not divide in. 6 does. So if I do 6 times 12, -6 times 12. All right, 7 does not go. 8 does go though. So I could have 8 times 9 or -8 times 9. And sorry, I'm looking at some of my work and these should all be negatives. So I think I should have a -18 here and a -12 here. And how I can start to tell that I'm done is if I take 8 and I square it. 8 squared is 64, but 9 squared is 81. And since I went over that number 72, then I know I'm done. All right, and so what I mean by that is 1 squared is 1, that's not larger than 72. 2 squared is 4, not larger than 72. 3 squared is 9, not larger than 72. All the way down to I finally got this factor of 9. So since 9 squared is 81, and it is larger than 72, I know I'm done. All right, because I've tried every number between 1 and 9. Okay, so we have that. We've written out all our products. The next thing we need to do is take a look at the sum of those numbers and see which would sum to our middle term of 18. All right, so if I try this, I'm going to kind of start to make a little grid. Give me a moment to just grid these up. I'm going to look for which of these possibly sum to positive 18. And whichever ones do, if any do, that's going to be the one I want to pick. And if none of them do, that's fine. Then my trinomial is prime. All right, so 1 plus 72 is 73. That is not 18. That's not going to be my answer. -1 minus, or I should say plus a -72, which is -1 minus 72 is -73. Also not my answer. All right, 2 plus 36, that's going to get me to what? 38, not 18. And anything negative, right, not going to work. So I can rule the next one out. I can actually rule all of these pairs of negatives out. So let me just put X's between them just to kind of save myself some time. All right, 3 plus 24 is going to be, what do we got, 27, not 18. All right, what do we have here? 4 plus 18 is 22. That is also not 18. 6 plus 12, aha, 18. All right, I unlocked it, right? I unlocked it. So 6 times 12 is 72. And at the same time, 6 plus 12 is 18. So that's going to be the term I want to go with. All right, so I'm going to scooch this down just a bit and see if I can get all of this in. So let me, just for the sake of having some space, let me erase the 8 and 9, just so I have some space to write all on the same screen. Okay, so I found the term that unlocked. All right, so what I'm going to do, I'm going to rewrite my original trinomial. All right, we're going into step 3. We're going to replace step 3 of the stuff written up here. We're going to replace the 18R, the middle term, with the sum of the like terms that I circled. So what I mean by that is I'm going to replace 18R with 6R and 12R. All right, so I'm going to split the middle term. All right, so instead of 18R, I'm going to write 6R and 12R. And I'm going to tell you, if you'd written it in the opposite order, this still would have worked. All right, so now we have 4 terms. We're going to factor by grouping, right? We're going to go back to all of that stuff that we talked about in example 2. And when you're doing this AC method, you can always group the first 2 and the last 2. So here we go. What's common to R squared and 6R? R. If I factor out that GCF, I've got R times R plus 6. What's common to 12R and 72? 12. And I'm left with R plus 6, right? Since these back binomial factors match, I can factor it out, and I am left with R plus 12, right? And if you wanted to check this, you could FOIL, right? R times R is R squared. Outer, 12R. Inner, 6R. 12 and 6 is 18, and then 6 times 12 is 72, all right? So I did factor my trinomial, and you could make the argument that it was easier to guess and check, not denying that. I'm just saying here is a way that will definitely get you to an answer. All right, so let's try this again. Again, lead coefficient of 1, so my life's a little easier. I've got a equals 1, b equals -9, c equals -36. All right, so I'm going to draw a little separation line here, and let's talk about the product. All right, I want to look at a times c, which in this case is 1 times -36, which is -36. Okay, so let's start making some products. Okay, I could do 1 times -36 if I wanted to, or I could do -1 times 36. All right, 2 goes in there, so I could do 2 times -18 or -2 times 18. 3 goes in, so what do we have? 3 times -12, -3 times 12. And if I'm kind of keeping track, 3 squared is not greater than 36, so I can keep on going. So let me go to the next number. What do we got? 4. 4 does go into 36, so I have 4 times -9 or -4 times 9. 5 doesn't go in. 6 goes in because this is a perfect square, so I could either have, I don't have to write it twice. So you can have 6 times -6. You could write -6 times 6, but it's going to add to the same thing. All right, let's see what sums are we getting. And we want a sum to b, which is -9. So let me see what starts summing here. And we'll see what we can unlock. And again, if we don't unlock any, then we just say this trinomial is prime. All right, so 1 plus a -36 is -35. That's not 9. Excuse me, that's not -9, so that's not it. -1 plus 36 is +35. Also not it. All right, 2 plus a -18. 2 minus 18 is -16. That's not it. So this next one won't be it. All right, 3 plus a -12. Aha, is -9, right? I unlocked it. All right, so for the sake of just having a little bit more space, let me erase all this work here, just so I can head on into step 3 from all of those instructions above. Okay, so I've got a little bit more space now to do some work. Oh, those numbers are still showing through. I should have used my fancier eraser. Okay, so we unlocked it with 3 and -12. So I'm going to rewrite my original trinomial. All right, so I'm going to rewrite -9x as x squared plus 3x minus 12x plus 3x minus 12x. I'm going to split that middle term. All right, so 3x minus 12x is -9x. But now that I have my 4 terms, I'm going to go ahead and factor by grouping. And to be clear, if you had written this as -12x plus 3x, you would have gotten to the same endgame answer. You would have taken just a slightly different path. All right, so let's factor out x from here, and I got x plus 3. I'm going to take the negative with it, so -12, x plus 3, and my back binomial factor matches as I want it to. So I'm going to factor out x plus 3, and I'm going to be left with x minus 12. And if I wanted to check, I could FOIL this, and when I get back to my original expression, I know I've done it correctly. All right, so let's start working on this with some other examples. So I'm gonna scooch the page over, and we might lose focus for a hot second. All right, but let me go ahead, move this down, see if I can kind of get this straightened out. All right, and let's take a moment and really compare C and D. Right, I want you to notice that C and D look similar, but this has a -24 here and this has a +24 here. And I want to point that out because it's going to come into play. All right, so if I start to work this, right, let's go with, we know A is 1, B is -5, and C is -24. All right, so just for the sake of kind of forwarding this a little bit faster, right, if I wanted to think, and I want to make sure that you got room to see this, if I did the product here of AC, that in this particular case would be 1 times -24, which would be -24, okay? So if I think about the numbers that could multiply to -24, but again, we want to sum to -5, right? We can start to write an exhaustive list, 24 times 1, but that's not going to get us there, right? Because 24 and 1 whether they're positive or negative, it's going to get us to like 23, 25, or negative 23 or negative 25. That's not going to be it. I also could look at 2 and 12, but that's, if I start to add those might be 14, or if I subtract them, 10. That's not getting me to negative 5, right? Then I go to the next one. I've got 3 and 8, and that's what I want. Because if you hear 3 and 8, if I hear, I'll just put 8 here and 3 here. Now so far, 8 times 3 is positive 24. And I need it to be negative 24. So either I have a negative 8 and a positive 3, right? Or I have a positive 8 and a negative 3. But if I want it to sum to negative 5, right? If I want it to sum to negative 5, then I need the negative 8 plus 3 to get me the negative 5, right? So that's how I unlock it. All right, so let me show you a couple ways, because I want you to see that it doesn't matter if you had written negative 8 times 3 or 3 times negative 8. So going with the way I wrote it, right, I can take this x squared minus 5x and rewrite it as minus 8x plus 3x minus 24, right? If I did the negative 8 first and the positive 3. Okay, let's group. Factor out the x, I get x minus 8. Factor out 3, I get x minus 8. Fantastic. Now my back factor, that binomial matches, so I'm going to factor out the x minus 8, and I'm going to be left with x plus 3. Okay, fantastic. Now I want you to see, if I split this the other way, if I did x squared minus 5x minus 24, if I had written the 3 first and then the negative 8, right? So what happens when you do x squared plus 3x minus 8x minus 24, right? If I had written them in the opposite order, so here was negative 8x plus 3x, here it's 3x minus 8x. Same end game answer. Group, group. Right? I'm going to factor out the x plus 3. I'm going to factor out the negative 8, right? X plus 3. My back factor, this binomial of x plus 3 is common. Factored out, what am I left with? X minus 8. And these are the same answer, right? Because again, multiplication is commutative. It doesn't matter if you do x minus 8 times x plus 3 times x minus 8, same expression. Because something like 3 times 4 is the same as 4 times 3. We say multiplication is commutative. Okay, so I want us to take a look at D, right? C and D look similar, but this plus 24 is going to make all the difference on how we try and factor D. So I'm going to remind you, A is 1, right? B is negative 5. C is positive 24. All right, so let's rework this. And let's go ahead, and I'm going to write out the exhaustive list again. So we're going to do AC, which is 1 times 24, which is 24, right? And then I want a sum to be equaling negative 5. All right, so if I think about this, I could have 1 times 24, negative 1 times negative 24. And I can have 2 times 12, negative 2 times negative 12. I could have, what, 3 times 8? Negative 3 times negative 8. I could have 4 times 6, negative 4 times negative 6. All right, 5 doesn't go into 24 evenly, and 5 squared is greater than 24, so I know I have my exhaustive list. All right, let's check out all of these sums. Okay, so as I look here, right, we've got 1 plus 24. That's 25. That is not equal to negative 5. I essentially have negative 1 minus 24. That is negative 25. Also not equal to negative 5. And I can start to eliminate anything with the positives, right? This is not going to work because it's not going to sum to a negative. Positive 3 times 8, not going to work. Positive 4 times 6, not going to work. So I have some x's that I don't even have to check. All right, let's look at negative 2 minus 12. That's going to get me negative 14. That doesn't work. If I look at negative 3 minus 8, that's going to be negative 11. That doesn't work. If I look at negative 4 minus 6, that is negative 10. That doesn't work. None of these work, which is fine. What we would say here is this particular trinomial is prime. There is no way we unlock it. And totally fine. It's a matter of recognizing it. So that's where this AC method can be helpful. It helps you create this exhaustive list, right? And then you can see, like, just none of them worked this time. Okay, So let's take a look at E. All right, let me scooch E up. So we've got that. All right, now before I really get going on E, things to notice is that there's a GCF in play here. Okay, so I got negative 3x to the fourth, 15x cubed, negative 18x squared. I also don't like the fact that I have a lead negative, and specifically I have a lead coefficient that isn't 1. So what I'm going to do is I'm going to factor out my GCF, and I'm going to write this here. My GCF for this particular problem, right? Negative 3, 15, and negative 18. That greatest common factor is negative 3. Between x to the fourth, x cubed, x squared, I take the least of those powers. There's my GCF. Okay, so let's take out negative 3x squared. Negative 3x squared to get to negative 3x to the fourth leaves me with an x squared. Negative 3x squared from positive 15x cubed is negative 5x. Negative 3x squared from negative 18x squared is going to be plus 6, right? So then if I'm trying to AC method this one, I'm going to have A is 1, B is negative 5, C is 6. So we can go through, right? We could do product, right? It's always AC, which in this case is 1 times 6, which is 6. And then we can sum. Oh, and let me make sure you can see all of this. I think I'm getting too far to the right. Let me move the paper so that we can see it. All right. I think we can see it. All right, sum in this case, can we see my, yeah, I think you can see the edge here. Sum is going to be what, B, which is negative 5. Okay, so we've got that happening. Let's see what we got. All right, what multiplies to 6 and adds to negative 5? I'm going to go directly to, I can see this as, let's see, we could have 1 times 6, negative 1 times negative 6. And then the other one would be 2 times 3 or negative 2 times negative 3, right? Okay, let's see what we got. 1 plus 6 is going to be 7. That's not going to be it. And I can also rule out 2 times 3. Those positive numbers are not going to add to a negative. Now, negative 1 minus 6 is negative 7. That's not it. But negative 2 minus 3 is negative 5. I found it. All right, so I've unlocked it. So let me keep this negative 3x squared out. All right, I'm going to rewrite this, and I'm going to put them in brackets just so we can kind of split it. All right, x squared, instead of negative 5x, I'm going to write negative 2x minus 3x plus 6, right? So instead of negative 5x, I split that middle term. And sometimes you'll hear this method referred to as splitting the middle, and that's where it comes from. All right, let me scooch this over just so it's not super, super cramped, okay? All right, now I've got to factor by grouping. I'll take these two and these two. So I'm gonna have what, negative 3x squared. All right, I can factor out an x here and be left with x minus 2. I'm gonna factor out a negative 3 here and be left with x minus 2. My back factor, that back binomial matches, great. So I've got negative 3x squared, and then what do we have here? Let's do, I factor out the x minus 2, and I'm left with x minus 3. And let me just clean it up. I don't need brackets and parentheses, so my end game answer, negative 3x squared, x minus 2, x minus 3, right? Okay, so let's try this last one. Like, what do we do when we have two letters? All right. So as I look at this, right, I would still have A is 1, B is negative 3, C is negative 4, right? That is still happening here. I get that we have A, B's and all of that, but the coefficients are still 1, negative 3, and negative 4. So as I start to look at this, right, if I do product, all right, let's do AC. We're going to have 1 times negative 4, which is negative 4. All right, and I want to sum to that middle term of negative 3. And I want to acknowledge that we're double using the letters A and B, right? I know there's an A and B in the actual original problem, but when I refer to A, B, and C here, I'm talking about the coefficients. Okay, so let's think about what on earth could multiply to negative 4 and sum to negative 3. And maybe you actually already see it. It's written here, right? 1 times negative 4 is negative 4, right? And 1 plus a negative 4 is negative 3. All right, so let's go ahead and work this. So if I have b squared minus 3ab minus 4a squared. I'm still going to split that middle term, and I'm going to split it with ab minus 4ab. All right, so this is going to be b squared plus ab minus 4ab minus 4a squared. All right, so 1ab minus 4ab is negative 3ab. It's going to group. All right, let's group these. So what's the GCF between b squared and ab? Well, b, and I'm left with b plus a. Okay. All right, what is common to negative 4ab and negative 4a squared? Well, I'm going to factor out the negative 4a, and I'm going to be left with b plus a. And then that back factor, that back binomial matches, right? So I'm going to factor that out, and I'm going to be left with b minus 4a. Yeah. And what I would really recommend, especially when you get to these two-letter type problems, is that you FOIL and check, right? b times b, b squared, right? Outer, b times negative 4a, negative 4ab, right? b times a, inner, positive ab. Negative 4ab plus ab, sure enough, is negative 3ab. And then last, 4a times, positive a times negative 4a is negative 4a squared. So you can always check with FOIL. All right, so thank you for sticking with me on this example. It's a super long one. All right, see you soon. Bye.